Okay, so we're going to go through distributive property. And it's commonly called FOIL. Sometimes they call it the rainbow method. It's essentially the idea that you take both of the numbers. These are binomials. In other words, there's two in each, and you're multiplying a binomial by a binomial. So two numbers by two terms by two terms. Because they're in brackets, FOIL, rainbow method, whatever you call it, is the idea that you take each of the numbers in the first bracket and you make sure you multiply it by both, and take the other number in the first bracket and make sure you multiply it by both. This is where you get the rainbow hoops. And FOIL stands for the idea is you multiply the first terms, so this would be x times 4x by each other, the outside terms, okay, and the outside terms are x and -2, the farthest to the outside, the inside terms, which is 3 times 4x, and the last terms, so L, which is 3 times -2. So if you really notice, I've underlined everything twice, and that's kind of what needs to happen, okay? We've done the first term by both of these, right? So he had a green and a blue, and here's a green and a blue. It's split. He had a purple and a red, and here's a purple and a red. So he's been multiplied by both, okay? So whatever method you use to remember it is fine. So let's kind of go through this idea, though. X times 4x, okay? And we'll do each of these kind of on the side. Those are our first terms. So what would x times 4x be? Do you know?
Is it 4x squared?
That's exactly right, 4x squared. So I'm going to write that in. That would be my 4x squared, okay? The next thing we did was the outside terms, and that would be x times -2. So what would x times -2 be?
-2x.
-2x. So I write it in as minus 2x. The inside terms are the next ones. Okay, so inside terms were 3 and 4x.
So 12x.
That's right, 12x. So because it's positive, we put a plus sign, so we have positive 12x. And then the last one is 3 times -2.
-6.
Excellent. So we subtract by 6. Okay. So we've written all the terms, and you can kind of do inside calculations. If you can do it in your head and get to this step, then all the power to you. You just kind of go for that. Next, we want to collect like terms. Now, I know it's all on different colors right now, but there are a set of like terms in here. Do you know what they are?
4x squared, -2x, and 12x.
Okay, very, very close. One of these terms technically has a different exponent that you said, so that doesn't make it a like term.
Oh, the 4x squared.
Aha, so what would be the two like terms?
-2x and 12x.
Excellent, yeah. And what exponent is each of these variables to? Do you know?
1.
Yeah. So that's what makes them like terms. Okay, excellent. So we're just going to combine those two. These guys, there's nothing like them, so they're going to stay the same. So we're going to get y is equal to 4x squared. And what would -2x plus 12x be? Do you know? Think of it like -2 plus 12. So we're kind of taking 2 away from the number 12 in this case.
10, -10?
Yeah, well, it won't be negative because the positive value is larger, so it'll be positive 10. Okay, does that make sense?
Yeah.
Great, so then we subtract 6 after. And that's it. This is actually called the standard form. We've actually gone from the factored form to the standard form of a quadratic right now. Standard. Okay, great. So with that being said, I'm going to go to, and usually don't do 2 examples. We're going to jump into a really hard example. Okay, here's the idea that there's a square being built. Okay, so we have some square, and I've been told that this is 2x minus 2. Okay, and we want to find the area of this square, and there actually happens to be, I don't know, 3 of them, let's say. So there happens to be 3 of these squares. Oops, that's the wrong one. Okay, so just keep in mind there are 3 of these. Okay, now if it's a square, that means this side is how large?
It's the same size.
Yeah, so it's 2x minus 2. So a lot of times something like this is written as 2x minus 2 squared. If we're trying to find area, we have to multiply the 2 of them together, right? So it's squared right now. Okay. Also remember, how many squares are there?
3.
So whatever the area of this square is, what do I have to do?
Multiply by 3.
I gotta multiply by 3. So I'm gonna have to multiply this by 3. So I put a 3 to the outside. Okay. So I've just created a common distributive property question from a geometric question. Okay. they're going to ask us to expand and simplify. So this says y is equal to 3. And now when we have those two brackets, or we have a bracket that's squared, we can rewrite it as 2x minus 2 times 2x minus 2. Okay. Now I'm just going to say the FOIL part out loud, so hopefully we're okay with it right now. We'll multiply 3 at the very, very end. So let's do the first terms. What's 2x times 2x going to be? 4x squared. Great. Then we would do 2x times negative 2.
Negative 4x.
Beautiful. Negative 2 times 2x?
Negative 4x.
Yeah. And then negative 2 times negative 2?
Positive 4.
Great. What are the two like terms?
Negative 4x and negative 4x.
So together, what would they become?
Positive 16.
You multiplied them. In this case, think of it like negative 4 minus 4. Okay? So we're actually going to subtract that value. Okay? So in this case, it would be negative 8. But that's a common error. So keep in mind, once we've done this multiplication, we have to go back to addition and subtraction. Okay? Plus 4. Finally, now that we've simplified that part, this 3 has to be distributed to everything. Okay? So when we distribute that 3, we're going to get 3 times 4x squared. Do you know what that'll give us?
12x squared.
Excellent. 3 by 8, or negative 8, will give us negative 24x. And then finally, 3 by 4, where do you think that goes? Great. 12. So this is actually the area of 3 of those squares. Okay, so 1, 2, 3. That expression represents the area of all 3 of these squares. Okay, and we use distributive property twice when we were multiplying a binomial by itself and then a single number to each of the terms inside.